In this video, we're going to look at dividing radicals, and notice in this particular problem, in example 1, our indexes are the same. So just keep that in mind, that the index of your root must be the same to divide. Now I'm going to go ahead and I'm going to take the radicand of 2 and I'm going to be dividing it into our radicand of 250. So if I get my calculator and I divide that out, I end up with 250 divided by 2, and it gives me 125. So this is actually equal to the cube root of 125. Now anytime you get an answer, once you do the division, you do want to put it in your calculator to evaluate it, to see if it'll give you an integer, or to see if you need to simplify it. So I'm going to go ahead and give it a shot. I'm going to hit math, go down to my cube root, which is option 4, enter, put 125, and notice it gives me 5, which means that 5 multiplies to itself 3 times to give me 125. And so that is my final simplified answer. Now in example number 2, notice we have 2 different values, and we can see if this can be simplified later on, but what I want to do first is I want to go ahead and simplify each one of these as an individual radical. For instance, I have the cube root of 54, which I'm going to simplify, and I have a cube root of 125 that I'm going to simplify. Now once I simplify them, then I'm going to go ahead and do the division and see where it leads me. So in this first one, I'm going to see what I can break down 54 into. So I'm going to use my prime numbers. So I'm going to use 2, 3, 5, 7, 11, and 13. And one of these numbers should work for breaking this down. So I'm going to start with 2. See, can 54 be broken down by 2? And it does. 2 and 27. Now I know that 27, that's a cube root that I actually know, because there's a number that can be multiplied to itself 3 times that will give me 27. So I'm going to stop there, because this is what I would call a perfect cube root. And so this breaks down into square root of 2, or not square, but cube root of 2 times the cube root of 27. So now that I've broken this down right here, I can go ahead and simplify it. So I'm going to put cube root of 27 in my calculator, and it gives me 3. So this up here just becomes 3. And then this other one is what we call a surd. It can't be broken down any further. And evidence of that is that it is a prime number, right? So the 2, notice, right, it is a cube root of 2. So that's as far as it can be broken down. And I'm going to rewrite my division problem in just a minute, but now using this value. And I'm going to do the same for the cube root of 125. So I get my calculator. I'm going to check and see, can that be evaluated to a whole number? So 125, and that gives me 5. So I didn't have to break this one down, but just to show you, if I were to break it down, if you didn't realize that that was a perfect cube root, you could have broke it down and said, you know what, we can get 5 and 25, because you notice that 5 is a prime number and we can divide it into it. And then we could have broken it down further and said, well, that's going to be 5 and 5. And then what would have happened is you would have had a cube root of 5 times a second cube root of 5 times a third cube root of 5. And remember, with cube roots, anytime you have 3 of the same root, it just turns into the number. So this really just turns into a 5. And we can use that in our division problem. So when I write my final answer, I'm going to go back and write this as a fraction, but now using these simplified cube roots. And so the first one is 3 times the cube root of 2 over 5. And 3 over 5 can't be further simplified. You can always check it by using alpha y equals enter to get your fraction bar. Put 3 over 5 and see what does it give you. And notice this, it stays exactly the same. It's just 3 over 5. So that is our final answer.